Section 7.5, Inverse Circular Functions. So in this section, we will be reviewing the inverse trigonometric functions, particularly sine inverse, cosine inverse, tangent inverse, cotangent inverse, cosecant inverse, and secant inverse. Before we get into that, let's take a few minutes to review just the general concept of what an inverse function is. So if you read at the top, first, we need to know something about a one-to-one function. A function is one-to-one if and only if every y value corresponds to only one x value. Okay, so you have to read that again. A function is one-to-one if and only if every y value corresponds to only one x value. Okay, so I'm going to give you a quick example of something that is not one-to-one. So a simple function from algebra, nothing trigonometric. Okay, so I'm just going to draw my x and y axis here. Okay, if you think of the basic function, f of x is equal to x squared. Okay, if you think about the points on this graph, this is a parabola. It goes through 0, 0, and then it goes through 1, 1, 2, 4. Okay, and then the graph is symmetric about the y-axis, so it goes through -1, 1, and it goes through -2, 4. Okay, so you get this parabola out of it, and when you look at it, and this is just a rough sketch like I said, you see that we have some repetition among the y values. Okay, so this point was 2, 4, this is 1, 1, this is -1, 1, and this is -2, 4. Okay, so again, if you read the definition, every y value has to correspond to only one x value. Well, we have a problem. Okay, there's a lot of issues, like lots of points that violate the rule here, but I'll just take these 2 points that I've highlighted in yellow. Both x equals -2 and x equals 2 share the same y value. Okay, so you have repeated y values. This fact makes this function not one-to-one. Okay, you can use something called the horizontal line test, which is stated below, to determine whether or not a function is one-to-one. Now remember, there's vertical line test. Vertical line test is to determine whether or not a function is whether or not a graph represents a function. The horizontal line test is used to determine whether a function is one-to-one. Okay, so the reason this violates the horizontal line test is there is at least one spot. Okay, and I'm trying to draw this through those 2 points. There's at least one spot where I can draw a horizontal line, okay, that it's going to intersect the graph in more than one point. Okay, what it's doing here, this horizontal line test, it's catching points on the graph that share the same y value. Okay, so that makes it not one-to-one. Okay, so why is this important? Okay, well, here we go. The reason that this is important is for an inverse function to happen. Okay, well, I'll put it this way: for a function to have an inverse function, the function must be one-to-one. Okay, so only one-to-one functions can have an inverse. Okay, so let's go ahead and read about what an inverse function is. In the box, this is like a formal definition, and if you read through this, it's sort of confusing. Okay, so after we read through what's in the box here, we will kind of diffuse this. Okay, all right, suppose that f is a one-to-one function. Then to each x in the domain of f, there is exactly one y in the range because f is a function. And to each y in the range of f, there is exactly one x in the domain because f is one-to-one. The correspondence from the range of f back to the domain of f is called the inverse function of f. The symbol f inverse is used to denote the inverse of f. All right, so that is quite a headache that's in the box there. Okay, so if you translate this and put this in layman's terms about what does this inverse idea mean, look right here. Okay, this is kind of a translation. It says think of the inverse of a function as the reverse of that function. The inverse function undoes the operations that were done on the function. Okay, so again, you want to think of it as the reverse. It is undoing the original function. So for example, I will make something up here. If I just have something really simple, like f of x is equal to 2x minus 5. So with a function, you plug something in, that's your variable. So here we're plugging in x. So what does this function do to x? Well, if you follow the order of operations, the first thing it's going to do is take that x value and multiply it by 2. And then after that result is achieved, it's going to take the result and it's going to subtract 5. Okay, so if we were to look at the inverse function here, okay, the inverse function is going to be x plus 5 over 2. Okay, there is a way to come up with this. You've probably learned this in algebra. I just didn't magically pull that out of my head. But what this inverse function does, and notice the notation, this f, it looks like you're raising it to the -1, but that's not what you're doing. It means f inverse. It is undoing what the original function does. Okay, so now if we have an input to this particular function, watch what happens. Okay, we're undoing the original function in the reverse order, kind of. Okay, the first thing we're going to do here, if you take x and you follow the order of operations, you're going to add 5. That is undoing the subtraction of 5. And then the next thing you're going to do is you're going to take that result and you're going to divide by 2. Okay, and that's the opposite of multiplying by 2. Okay, all right, so that is what an inverse is in a nutshell. You can kind of see it better if you plug a number in. Like if I say x is 0, okay, so if x is 0, then f of 0 is equal to 2 times 0 minus 5. That's -5. Okay, and then if that becomes my x value and I plug this -5 into the inverse function, okay, that's going to give me -5 plus 5 over 2. That's going to be 0. Okay, it brings me back to where I was. Okay, so basically, if I start with an input of 0, the original function spits out an output of -5, and then if that output -5 is if it's put into the inverse function, out comes the original x value 0. Okay, it gets sent back to itself. Okay, so it undoes what the original function did. Okay, all right, so here are some great facts to know about a function and its inverse. Number 1, if a function is 1-to-1, it will have an inverse function. Number 2, if a function is not 1-to-1, it may be possible to restrict its domain in some suitable manner so that the restricted function is 1-to-1. Okay, I'm going to give you a big hint. This is going to be key when we're doing inverses with trigonometric functions. Okay, we'll come back to that. Number 3, the symbol f inverse is used to denote the inverse of f. The symbol f inverse does not mean 1 over f. Okay, the reason that is mentioned is if you have a variable x, okay, I'm talking variable, not function here. You've probably seen this before. Like if I say x to the -1, you can eliminate that negative exponent. Actually, we talked about this when we were studying properties of exponents back in section 4.5. How do you eliminate a negative exponent? You do 1 over the whole thing and you change the sign of the exponent. Okay, so yes, that is true for a variable. But if you see a function name like f or g or h that looks like it's raised to the -1 power, this is not what it's indicating. It's not saying do 1 over the function and change the sign of the exponent. That's not what it means. That is just indicating that it's an inverse function. Okay? All right, another biggie for inverses in number 4. If xy is a point on the graph of the original function, then if you just flip the x and y values to get the point yx, that's going to be a point on the graph of the inverse function. Okay, absolutely critical for inverse functions. Okay, so one more time, if you're looking at the graph of the original function f and the ordered pair xy is a point on that graph, then if you do a switcheroo and you look at the point yx, that's going to be a point on the graph of the inverse function. Okay, number 5. The graph of an inverse function is the reflection of the original function about the line y equals x. Okay, so something cool, if you take the original function and the inverse function and you graph them on the same grid, they are reflections of each other about the line y equals x. Okay, if you fold your sheet of paper along the line y equals x, the inverse function and the original function will lie on top of each other. All right, number 6. The domain of the original function f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse. Okay, another important thing. Okay, and this is tied to switching the x and y. Okay, so if you switch the x and y, remember x is domain, y is range. Okay, so if you switch x and y to get the inverse, okay, that's going to flip the domain and range. Okay, so one more time, the domain of the original function, the domain of f, is equal to the range of f inverse, and the range of f is the same as the domain of f inverse. Okay, 7 and 8 have to do with composition of functions. So if you remember composition of functions from algebra, you're basically plugging a function into another function, and order of composition matters. Like if I do the function f composed with the function g, that is probably going to be different than the function g composed with the function f. Okay, however, if you are dealing with a function and its inverse, if you compose them in either direction, you're going to get the same thing. And furthermore, the quantity that you get is going to be x. Okay, so what this is saying in number 7 here, okay, this f inverse of f of x, that is f inverse of f of x. Okay, so the composition would be f inverse of f. If you do that, it's going to result in x. Okay, but if you switch the order of the composition in number 8 and you do f of f inverse of x, okay, when you do the composition in that order, you're also going to get x as the result. Okay, so if that happens, you compose a function with its inverse in either direction and you end up with x in both situations, that indicates that the two functions are inverses of each other. Okay. All right, so now that we have rehashed the basics of inverse functions, we are going to start looking at inverse trigonometric functions.